In our probability unit, you're going to see that probability can get complicated very quickly. One of the things I'm going to constantly encourage you to do is to make a picture. Venn diagrams and two-way tables will make your life easier. On the screen, you should see 3 Venn diagrams. Here's an example of the complement rule. Again, think of A as your event. So if this is the probability that it's raining in this circle, the probability that it's not raining is out here, which is why we saw that our complement rule is the probability of A complement is equal to 1 minus the probability of A occurring. We saw that the intersection of 2 sets is the area where your circles overlap. So the intersection of events can be written like this: the probability of A intersected with B is the set of all outcomes in both events. Okay, remember that an upside down U is for intersection. It's kind of like that N there for the intersection of the two. Whereas the union of 2 sets is where you're just adding your 2 sets together. So it's everything in A or in B. And what you've got to be careful we're going to see is that we don't double count the overlap. We look specifically at mutually exclusive events in the first part of our lesson. So we saw that if we have mutually exclusive events, we are talking about 2 events that can't possibly happen at the same time. Or another way of me saying that is, well, there's no overlap. And as long as they are mutually exclusive, we can just add the probabilities together. So if they are mutually exclusive, again, what this is showing you is we're just adding the 2 together because there's no overlap, we're not double counting anything. Now, let's go to the general addition rule because it's more likely that if we have 2 events, it occurs much more often where these 2 events overlap one another. So you have this common region here in the middle that if you just add your 2 events, you're going to end up double counting. So that leads us to the general addition rule, which says the probability of A union B is equal to, yes, we just add them, but that means we've double counted. So what we need to do then is subtract this overlapped region in here. And how we subtract that, again, that is the probability of the 2 being intersected together. So intersections, the upside down U like this. Okay. This general addition rule here is actually on your AP formula sheet. I encourage you to pause the video and actually find it so you are familiar with where it's at, because come AP exam time, you're going to want to know how to use that sheet. So let's look at this scenario that is not on your note guide. It's just one to think through with me. So we're going to make a Venn diagram where it says a survey of all residents in a large complex reveals that 68% use Facebook and 28% use Instagram, and then 25% do both. So the first thing I'm going to do here is I'm going to make 2 sets and I'm going to make them overlap here. So I'm going to say that this circle represents those that use Facebook. Over here would be Instagram, and then of course here in the middle is the both. Here's my hint. If you know it, or even if you don't, I always try to find the intersection part first in the middle. It's just how my brain works. And I'm going to write relative frequencies here in the middle, so 0.25. And then I have 68% use Facebook. So this whole circle has to add to 68, so I need to subtract this 0.25 from it, which gives me 43%, so that would be 0.43. Similarly then here for Instagram, 28% use Instagram, 25% are also using Facebook, then there's only 0.03 or 3% that are exclusively using just Instagram. Then what I do is I usually put this little rectangle, because what about the complement of those that use neither Facebook nor Instagram? So to get that number, if I just quickly sum these 3 values, that adds to, let's see, 71% are using some form of social media platform. So what percent are not? Subtract it from 1. So 1 minus 70, or 1 minus 0.71 would be 0.29 right here. Now I want to show you how this relates to a two-way table. So when I set up a two-way table, I'm going to use I for Instagram. So I have some that use Instagram, and then I have some that do not. So I'm going to do Instagram complement. Okay, and then similarly, I've got people that are using Facebook, and then people who are not using Facebook, so Facebook complement. And you'll often see that though there will be words written out, but for speed, I'm just going to use this notation, and I think that you'll be with me. Again, I start with those that do both. So 25% do both. So the intersection right here of Facebook and Instagram is 0.25. Okay, if I go to my relative frequencies. And then altogether, 28% use Instagram. So my total down here, total of my column, which would be a margin, is 0.28. So then that means 0.03 if I subtract, do not use Facebook, but do use Instagram. And then I'm told that 68% total use Facebook, so I'm going to put the total of Facebook as 0.68 here, subtract 0.68 minus 0.25 to get 0.43 right here. I also know that my probabilities need to add to 1, so if I do 1 minus 0.28, I get 0.72 right here. Similarly, 1 minus 0.68, I get 0.32. And then there's a couple ways I can get this value. I could do 0.72 minus 0.43. I could do this 0.32 minus 0.03, whichever you like. But all of them are going to give me 0.29. Okay. And then I can answer any amount of questions. And it's kind of just, what do you like better? What works better in your brain? I've found that I always gravitate towards a Venn diagram. Every once in a while, I find myself jumping over to a two-way table. But the thing that's nice about the two-way table is it really shows you every possible probability. Right here, you're going to have to do maybe some additional addition, but again, it's your choice. I don't think I've ever seen a question where they require you on the AP exam to use one specific method, or maybe I should take that back. I think I have seen one where they say make a Venn diagram, but often they don't tell you to use either, and I just highly suggest pick a picture and then answer the question. So anyway, find the probability that the person uses neither Facebook nor Instagram. Well, without even doing proper notation, I can see that's my 0.29 or 29%. Let's look at the example on your note page. A survey of college students found that 56% live in a campus residence hall, 62% participate in a campus meal program, and 42% do both. So the first thing I'm going to do here is I'm going to do some abbreviation. I'm going to let this be capital R for those that live in the campus residence hall, and those that participate in the meal program, I'm going to say that that's M. I just like to use a notation at first. And I notice question 2 is asking me to make a Venn diagram. So before I even read those other questions, I'm going to answer that. If it hadn't specifically told me, it's probably still what I would have done to begin. I'm going to label this circle R, this circle over here M. I'm going to put a box around it. And then I'm going to go right to the middle. And up here I see that 42% do both, so I'm going to put my frequency of 0.42 in the middle. 56% live in the campus residence hall. So all together in this left blue circle here, this is going to have to add to 56%. So if I do 0.56 minus 0.42, that leaves me 14%. The right circle, 62% altogether. So 42% are in the middle. That means 20% right here. And then what about that neither live in the campus residence hall nor participate in the meal program? Well, it's all got to add to 1. So if I add these three values, that's 76.76. So subtract that from 1, that gives me 0.24 down here that do neither. All right. Now that I've done that, that's going to help me answer all my questions. What's the probability that a randomly selected student either lives or eats on campus? So let me show you proper notation, how you would write this out. So capital P, lives on campus, was capital R that I defined above, or is union. Union eats on campus, meal plan. So folks, you could use the general addition rule here, which is probability of R plus the probability of M, and then you subtract the overlap of R intersected with M. Wrong letter there. But that would mean you're doing 0.56 plus 0.62 and then subtracting the overlap of 0.42. But folks, if you've done the Venn diagram, honestly, I just take these three, 0.14 plus 0.42, 0.2 on my calculator and say, okay, so this is equal to 0.76, right? You will see some, though, where maybe you're not given enough information possibly to make a whole Venn diagram. I can't really think of a scenario, but you might find the formula at times is easier. So we can jump to 3 now. The probability that you live off campus, let's write that with my notation. Off campus would be our complement, and so that's intersected with no meal plan. So no meal plan. So off campus would be outside the R, and then outside the M is this one down here, the 0.24. Probability that you live on campus, so that's R, intersected with meal complement, so no meal plan. So maybe I'll do some highlighting to show you this. So probability, where is it intersecting? So here's R and no meal plan. So what's no meal plan is anything outside. Anything outside the M circle would be all this region in here outside. So where did the two overlap? Where did the gray and the green overlap? It's this part, it's this little like Pac-Man circle, this 0.14. Okay, so I hope I'm convincing you that the Venn diagram is the way to go, or two-way table. All right, so police report that 78% of drivers stopped on suspicion of drunk driving are given a breath test, 36% a blood test, and 22% get both tests. What's the probability that a randomly selected DWI, that would be driving while intoxicated suspect, is given just any type of test? Again, even though this header says using the general addition rule, you can use the general addition rule. I advocate for make a picture. It becomes clearer. So let's say breath test, my notation for that will be BR, and blood test, I'm going to use BL. And so this one over here, BR, this one BL. Start in the middle. That's 22%, get both, 0.22. So breath test is 78%, minus 22% is 56%. Blood test, 36%, minus 22% is what, 0.14. And then get neither. When I add those together, it's 0.92, so 0.08 are going to get neither here in the corner. So the probability, first of all, number one, that you get a test. So probability that you get a test, I'm not even going to worry about proper notation. Well, these three values here, just you're going to sum those three. Or general addition is take the ones from here, this plus this, but subtract the overlap. I like to just add those three. Okay, so probability, number two, a blood test or a breath test, but not both. The Venn diagram makes that really easy to see. That's going to be this 0.56, that's your breath test. This is your blood test, but don't count those who are getting both. So 2 is going to be 2 is 0.56 plus 0.14. 70% of your people. And 3, probability that you get neither test, again, down there in the corner, there it is. Venn diagrams make these wordy questions so much easier. Okay, so according to a recent report, YouTube and Spotify are the most used music streaming apps. A group of AP Stat students surveyed all the seniors in their school, found that 68% use YouTube, 38% use Spotify, and 24% use both. Okay, now this is specifically telling us to make a diagram to display Y as YouTube and S as Spotify. And again, you make your choice, Venn diagram or two-way table. I just am partial to this, which I've clearly established by now. So using both, start in the middle, 0.24. Suppose I should label this. We'll make this Y and this S over here. Finish the Venn diagram. There's my Venn. Now find the probability that the person uses neither YouTube nor Spotify. And just to see if you can do proper notation for this, probability that they don't use YouTube, so YouTube complement, Spotify complement, and then it's the intersection of those. So that is the 0.18. You are going to do the check your understanding on your own and hit play when you're ready to check your answers. Before you do this, one quick tip, make sure that when you are dealing with a two-way table that you sum your rows and columns and make sure that they sum to the same thing. If it's probabilities, it would add to 1. This is raw counts, so it's not going to add to 1. All right, press pause. Okay, so there's my sums and everything adds to 500. Part A, the plain language would be it's the probability a person is not a high school graduate. That answer then would be, let's see, not a high school graduate is this right here, the 190 out of 500, which has a decimal or frequency would be, 0.38. Part B, why can't you just add the two? Well, clearly they're not mutually exclusive. We see that there are overlap. There's those who are both high school graduates and own a home. So how do we calculate that? You can try to work your way through the table, or you could do the add those who are high school graduates. That would be the 310. Add those who are homeowners, the 340. And then subtract the overlap if we go by the rule. So that's 310 plus 340 minus the 221. Not the only way to do it. You might be going, oh, did it a little different. I have multiple ways of doing that. That comes out to 0.858. And again, the explanation is because it's not mutually exclusive. Now we're making a Venn diagram. And this Venn diagram, I'm just going to again use, let's see, it was G and H for my events up here. And I'm going to use my raw counts, not the relative frequencies. So 221, I had 89, 119, and then 71 is neither. So I just copied my Venn diagram from our previous slide. Probability that is not a high school graduate would be graduate complement, but is a homeowner. So this would be and is a homeowner. And then we're going to find that probability. So I'm going to do that by kind of highlighting what that is in the table. So not a graduate, but is a homeowner is this area out here. So that's going to be 119 out of 500. Or 0.238. Okay, please reach out if you have any questions. It's time to do some practice.